into the lamp. Okay, that's not desirable. That is one thing. And another thing is that mostly in the most of this normal this LED lights in the markets, there are variety of suppliers are there. There are various suppliers, but normal what they do use like, see, it is a business for them, but we cannot just criticize or just discourage anything like that. Otherwise, it is not that every supplier is known about these all these aspects and to provide this quality of quality of drivers, all these things. For them, okay, ultimately you see that lamp needs some DC supply. How the okay, it is the see the just like a layman knowledge what it knows. Okay, it is a AC rectify. Put one small huge filter capacitor and put one large limiting resistor. Just okay, make it okay. This is working. This is a LED lamp, but there are high standard, high quality lamps also. That's why, of course, we see like the various brands. We say like Philips, Havels, other things. Okay, whatnot like. Okay, that means okay. We are expecting there, but the cost even every okay even the local supplier also he may put some brand name and he may just make use of that brand and you will sell it like it is also Philips other thing like that. But actually the inside the quality of the power circuit which is provided by that local supplier, okay, the all suppliers is not the same. That is what it's say. Most generally what they use like okay, see, a simple rectifier, one step down transformer and followed by rectifier and use large size filter the electrolytic capacitor and with a large limiting resistor, all these things. Again, these are all these, the very lossy elements and large size elements, okay, which makes the system more bulky and moreover like poor quality power driver. Okay, so that is the. So that is why we see this frequent failure of these LED drivers, LED lights. Uh, and this is mostly because of the failure of the components inside the power circuit. Okay. And also, even the fluctuation from the grid side. Suppose if you see this voltage fluctuations in the grid, which leads to the what is that? The frequent failure of this capacitor because basically this capacitor's life is mainly related to the number of charging and discharging cycles. Okay. So therefore, even with this fluctuations from the grid voltage side, which leads to this high ripple current and more flickering effect, and due to which that frequent failure of this capacitors and the other devices, diodes, something like. So these are all the most frequent issues because of the fluctuations, all these things like. And moreover, of course, that another thing is I said like the low power factor, the power factor issue on the source side. Okay. Uh, and moreover, this high grid voltage than the required low voltage for this LED drive. That means because the grid voltage says something like this 250, 230 volts, single phase AC grid. But we talk about this 12 volts or 24 volts operating voltage of DC voltage is the required value. Even after that rectification, just with the rectification, how to provide? See, what is the typical full wave rectifier output is something like a 2 Vm by 5. Vm is the what is that again root to VRMS. The 220 volts is the VRMS. That means like a 2 root 2 220 by 5. So that's the typical the rectified DC output of a full wave rectifier. So if that is the thing, typically like 190 to 200 volts DC is the after rectify, just direct rectification of that. But there we have just only a choice of either you use the EMI that before that rectifier, just a step down transformer of this power frequency, which is usually that leads to a huge weight of that lamp also. It becomes bulky. Okay, but that's not the desirable thing. But otherwise, if not, if you don't use that transformer, the step down transformer of power frequency, but then cutting down that such a ID almost 190 to 200 DC volts rectified into this 20 volts or 12 volts, it's not that's quite easier. Even with a most popular this DC-DC converters like a traditional converter like buck and buck boost converter, a simple conventional buck or buck boost converter from which from those converters also it's not that straightforward, it's not that easier to step down such a huge voltage diversion. Okay, like even converting from 200 to 20 volts almost 10 times, it's not that so easily possible. So there are some issues. Okay, and because all these things, see, when you are providing this higher grid voltage to the lower voltage, lower operating voltage of these LED drivers, so that is also one another issue of okay designing the effective circuit with a most compact size. Okay, and these generally these electrolytic capacitors, they are like no, their size is quite high, and the lifespan is very less even as because if you compare to the a thin film capacitors, so which provides much better life. Okay, high lifespan with even with the uh, size of these capacitors, which can be used in these LED drivers. Uh, in a very good quality drivers, normally they do use like even okay, yes, those thin film capacitors, okay, of a very small size and but it provides even good lifespan also. Yes. That is one thing. Okay, so these are the various issues, critical issues one can experience from these LED lamps, power circuits, both from source side and the load side is concerned. Okay, yeah. But obviously, of course, in order to utilize the best part of these merit factors of LED lights, because of their high energy efficient and very long lifespan and wide operating voltage and wide power ranges, and moreover, even this from these LED lights, we can also have a light output control also. Like that means even we can able to control the output of the lights. That means whatever the amount of brightness which we want, so that much of brightness is able to provide by controlling the by providing the dimming control feature in this LED lamps. So that is also possible. There is another added which such kind of future advantage is not possible in any of the other traditional lights, other things like that. Okay, so there is a very huge benefits in these advanced lights, but however, at the same time, there are several issues also. Okay, yeah, but all issues may not be resolved in even one design or like okay, because even see the lamp when you design, there is a like a universal voltage range. Universal voltage range, like suppose if I say there is a 110 grid, 110 volts single phase grid or like a 220 volts single phase grid. Like that means that, but if I just universalize, normalize, like no, so say 110 plus or minus some 10% something like that means some 90 to 230 to 40 volts. That is the universal grid supply voltage. So the driver which we provide, which I design for this LED lamps, that should be also able to cope up to see operate with this universal voltage range also. So there are several other issues, sir. Okay, it's not just only one issue. Like okay, even when it comes to this, especially providing the lower operating voltage from this from a conventional AC grid of like 110 volts or 230 volts. That's like a universal voltage AC grid voltage range. Okay, so that is it. So. Typically, yeah, this is what actually I was talking about. Something like, see, if I say this is the main LED lamp, okay, here. So this is our source. So I say we need a bridging element, which is the power converter, which is so called the power driver. Generally, we call it as okay LED power driver. So to power the LED lamp. Okay. So that is how it comes with like, okay, it's just a general say. And moreover, see, in order to operate this LED lamps, these lamps needs a typical consistently constant voltage and current. It should not be of like fluctuating voltage, even with a small, with a small ripple voltage, ripple current. So that leads to the flickering effect here in the, that is how, of course, normally you mostly we see as most of the time in the LED lamps, they are blinking continuously. It is because of that there is a the problem with that current and voltage signal, which is not a purely DC, which is going into that lamp. So as this triple voltage and current which goes into that, so that leads to this the flickering effect. Obviously, this continuous flickering effect, which leads to the continuous charge and discharge of this that capacitor, which is provided in the driver circuit, and obviously that is also usually which is that will have a limited life also. Even capacitors also will have their own limited lifetime. So that depending on the how many times the device which can charge, discharge, all this thing. So this flickering effect is too high. That means the triple components. Obviously, it indicates that the number of your this the charge capacitor, charge discharge needs to happen as so many several lakhs of times several. Okay, in that in the operating actual operating time of the lamp. So that is how these thing. Okay, therefore, these lamps needs a very stringent, regulated, constant voltage and current. That's one very, very important thing. One should remember uh, for designing a good driver circuit. Uh, okay. And also, yeah, so here otherwise it's not just now. Nowadays we have a standalone LED lights also. In fact, so in such case, of course, we can say directly battery paid LED drivers, or even we have a direct DC source kind of PV source, which facilitate the required DC power to feed our LED lights, because LED lights also needs a direct DC DC signal, DC power only. So that way, of course, we have advantage of using this solar PV directly for this LED lighting systems. But otherwise, it's not that all the time. Okay, we use this. Okay, standalone. But otherwise, for this AC grid power supply, so this is what we are concentrating like in most of the state like other things and okay, yeah. So and other thing is that the standards and classification. It is not just like okay, anybody can design a LED driver and we can just simply make it a lamp and we can sell it. No, So see, whatever things which we do that need to be comply with the some of the standards, okay, that international standards which is supposed to be followed by any followed for any of the product which we design. So for such standards and classifications here, so we have a different international standards. There are various standards, various classes of standards. Basically, that depends on the types of the applications and the equipments. So there are class A, that is for like especially for a three-phase system, three-phase equipment, household appliances, even excluding that class D audio equipments under such portable things under, which all comes under this class A IEC standard. And and other some unprofessional equipment, something like a welding equipment or lathe for some such kind of equipments and all, which comes under this class B IEC standards, which we are supposed to comply with. And for our lighting system especially, this IEC class C standards, which need to be followed or complied with respect to our lighting system design, equipment. Okay. So for that matter, if we just look at this, the standards, what they do see, they're like, means that is especially with respect to this harmonics order, THD, total harmonic distortion. So which is acceptable as per this class C standard for this lighting application. So the distortion with respect to the type of harmonics which is exhibit in that power circuit. So suppose if there is a lower order, third order harmonics, if it is present, the accepted the fundamental component as per this class C standard for this lighting application, it is just a sorry, 30% of this fundamental component, which is with respect to this third order harmonic exhibit presence. Similarly, if the order of the harmonics which increases, changes, so the perspective, the percentage of percent in the quantity of in percentage of its fundamental component, which is acceptable as per this glossy standard for lighting equipment. So this we are supposed to taken care when our design, whatever the design driver circuits which we design, such driver circuits need to be evaluate their TSD performance as per this standard, which is okay uh, demands. That it's supposed to be. Yeah. And nowadays, of course, even these LED lights become even very much significant in these automobile lighting systems, especially for various indicator lights, traffic lights, interior lights, whatnot, fog lights. So in several, that's what we can just look at, understand from this. And as per the driver configurations, depending on the types, the type of circuits components which we use. So sorry, which we have see, of course, noticed from the even literature also, we can understand like this. See, when we use all just only these passive elements like a step down transformer, uncontrolled rectifier, followed by just large limiting resistor and the capacitor. So a power circuit which is designed in that fashion, which is called to be, okay, considered to be a passive LED drivers. And otherwise, say we use this converter to by means of this active switch mode power converters. Now that is why, of course, it is more popular, right? So that's what we understand. We know very well about what is this switch mode power converters like. Okay, so their compactness is uh, uh, significantly much better, and they can be designed with a wide variety of power ranges with a very most compact sizes and with, okay, all these things. And that means the active switch, the transistor can be utilized in the switch mode operation. That is why the power circuits, power drivers which we have designed by means of this active transistor devices are called this active LED drivers. So that is okay, we can consider. But however, this passive drivers, there looks to be okay, simple and reliable. But however, see, they always need to be survive. You cannot provide the a step ripple-free DC current, which is the very essential requirement for the LED driver circuit. And okay, and moreover, of course, they may come with a very low cost, but they are very low efficient. They're not that much okay, uh, efficient in performance aspect because they are very lossy. Okay, and this active drivers, where in which this high frequency magnetics also we do use, so which contributes a large in designing the power converters with a very compact manner. And also we can able to operate these active switches with this even a soft switching mechanism, zero voltage, zero current. A lot of other aspects are there. With that way, even we can able to minimize the efficient power loss, switching power loss also, which so happened in this active uh, power converters. And that way we can also improve the overall efficiency of the power conversion system. And moreover, this these are the active converters, we can able to design the effective closed loop operation. So by which we can able to provide the precise output voltage regulation. Both we can able to provide the required constant output voltage and current, which is required for the LED light system. So that way they are more efficient and low cost and compact size. And then yeah, so as per the passive drivers, I said just to make you understand what exactly in the passive driver in a general normal local power driver circuit. Okay, what they do use, they just simply use. They know that okay, how to step down the AC voltage. As we know, this transformer step down transformer of the power frequency, and simply followed by this uh, what is that? This non-rectifier, uncontrolled rectifier device, rectifier bridge, and with a as large capacitor, and also to protect this means huge current like very high limiting high value of this current limiting resistor. So this is so called like a typical passive power driver circuit. So this may not be much efficient and other thing. Okay, otherwise, moreover, it always you need to survive with the this AC ripple component, which is not the advisable thing for good energy efficient LED lamps. Okay, and moreover, because of this rectifier and this what is this the capacitor, see it makes the source currents to be largely discontinuous in nature. and that means that creates a problem of the low power factors. That means, okay, it means that that indicates the poor, very poor utilization of the power source. Okay. Though we are utilizing this, all this power process is for the some purpose of, okay, utilizing the high bright lighting output, but at same time we are just creating other issues uh, by using this kind of uh, low quality and low performing power conversion process. That's the thing. Uh, it is one thing. Further to understand, further, of course, again, anyway, these are all based on uh, the existing information in the literature which we just uh, collected and studied upon. Sorry. Here, they didn't use this step down transformer, but right away they just use this large EMI source filter. But again, these are designed with respect to the power frequency of 50 hertz. They are not okay. Obviously, their size also much large only, size and weight. Okay. And otherwise, all these are uncontrolled devices and this passive capacitor and this thing. So, so here also we are not able to provide the mm, that required constant DC voltage and current. Okay, so those are the drawbacks when we uh, supposed to survive with this kind of driver circuits. So all these are considered to be the passive driver circuits. Okay, and there are, okay, like that several literature also which we can of course go through, because understanding studying all these kind of the understanding the existing work and existing literature in this particular direction, so that gives the real understanding of the things, uh, and also that will also remind give us the scope for improvement and the issues in the existing system, and to address that existing system, understand those existing issues, and and to think how to improve such issues, okay, with improved designs. So that is why I always say, any researcher, anyone, if he wanted to do something, we need to understand the first the fundamentals and the basic existing work thoroughly, and for which we have to study a lot. We need to just, okay, we don't get the information just like without the study a lot of research, uh, uh, existing uh, literature resource. Okay. Uh, so in contrast to those passive drivers, okay, there are active drivers. But again, here in these active drivers, there are various. This is as per the literature, the various researchers which they have devised and explored various configurations. But from that also we can just we can see those things can be classified like a single stage active LED driver, two-stage active LED driver, three-stage active LED drivers, like that. So that means, of course, every type of driver will have its own advantage and disadvantages. Possibly, of course, in the research, see that all these are okay possible. But for that matter, so one I say. this is called like a single stage switch mode LED driver, wherein which what is that single? See, because after this primary rectification process from the AC grid, right? Okay. So here, see, because here what we get, because we didn't use any transformer also, they have not used any step down transformer on this source side. So they are just directly powering from this 230 volt single phase AC grid just with a rectifier unit. Obviously, here we'll get a large DC rectified voltage, but this driver may need the very low operating DC voltage. So that means we cannot connect this rectified voltage, which is obtained after the rectifier, directly to the lamp. Okay, this I DC voltage. So obviously, it needs a one more conversion process like a step down DC to DC conversion process. So obviously this could be a step down DC DC converter. That's how I call it as a single stage. But however, just with the only step down conversion, okay, it may provide the process of converting the higher DC voltage to the lower voltage as required by this the LED driver. But otherwise, there could be some other issues also here, by the way. So one can, and moreover, the power capacity. So this is designed for this less than 5 watt rating. Suppose if you wanted to increase the wattage of the higher power rating, so this the converter which they have used here, a simple step down converter, may not be that suitable while providing this this 20, almost like approximately if it is like a 230 volt single phase AC grid, even roughly like 190 or 200 volts DC to step down to a very low voltage of like 12 volts or yeah, 20 volts or something like that. So it could be a quite challenging. That's okay. So all that such limitations can be understand okay by just studying in detail design process and operation of this converter. So that way we can understand the limitation, and moreover they use just only a simple electrolytic capacitors, and moreover this pulsate this current here if you can just see the current, though the source voltage is Q sinusoidal, but the current becomes the large discontinuous means it is okay. So this is a clear indicative of no the source current is largely distorted. That's because okay it becomes pulsating current which is not desirable, and moreover so that leads to the low power factor, low power utilization, poor utilization of the source, low power factor. So then what else need to be, even in that single stage process, there are some topologies which they have provided the process of both step down conversion process as well as the at the same time this converter is also working as this uh, power factor correction process. So that is how if you just look at the source current here, so which is quite in line with the source voltage. It's not like a previous one which we see. This source current is highly discontinuous, right? So that okay. So therefore the power factor is poor. But in the next one, if you can see, these converters perform this uh, step down conversion process. That means the uh, DC-DC conversion process, as well as at the same time it is also working as a power factor correction uh, circuit. Okay, but how that power factor correction is okay? There are two ways. Like because when we operate this converter under this continuous because we know that these converters can be operated in continuous and discontinuous. Uh, Discontinuous mode. So when we provide design this converter, this DC-DC converters in the discontinuous conduction mode, we can understand that this converter in a DCM, it operates as a like a voltage follower, so that the inductor current of this DC-DC converter, okay, which merely follows that peak where the peak current of this discontinuous current of this inductor will follow the sinusoidal boundary of that okay, the rectified signal.
Sir, excuse me, sir.
Yeah,
Excuse me,
please.
sir. Sorry to interrupt, sir. So
Okay.
actually, further we'll be having some online test exam and also feedback sessions are there, sir.
Okay.
So can you please, if possible, close the topic, sir? So, within less than 5 minutes, sir.
Okay, okay, that's fine.
Okay,
I'll stop.
okay, sir. Thank you, sir.
Okay.
Thank you so much.
Yeah. So that is how, so in case of a discontinuous mode, there is an inherent power factor correction, which is possible through this DC-DC conversion process. And if it is converter operates in the continuous conduction mode, so then there we need to go for the closed loop control, where in which we can sense the we can take a feedback of this rectified pulsating sinusoidal voltage and also the current, and that need to be compared with the output. Okay, feedback through error amplifier and comparator, all this such. Okay, some closed loop PFC correction operation we need to do, especially in this case of the continuous conduction mode of operation. So that means what I mean to say, there is a two possibility, the way of possibilities to achieve the power factor correction through this DC converters. And moreover, in this for this power factor correction, mostly uh, this boost converter or playback converter are most preferable one, but otherwise other converters, buck and buck boost converters, they are not preferable for the power factor correction operation, because the source side, their source current in this buck converter and the buck boost convert configurations, they are pulsating in nature, so they could not able to provide a steep current signal. Hence, this boost converter is preferable for such power factor correction operation um, in such a okay, in these kind of circuits. So that is fine. So like that, see the various designers, of course, and furthermore, like a soft switching principle. So they do incorporate, because that is possible in order to minimize the power losses, so that the overall efficiency can be improved upon. So, like that, as a matter of curiosity, of course, taking the variety of applications and the range of power wattage designed for these circuits, the classification also, of course, we have just made some different classifications of the driver circuits to be designed for depending on the range of power ratings, and also specific applications, and also the kind of what is that standards need to be comply with. Okay, all such things. So that gives like, okay. So therefore, there are several issues one can, work on, and of course, even for that matter, we have designed some converters, and this converter here, if you just anyway, I'll stop just in a very short time. See, for a matter of that, I step down conversion. This is a simple buck converter structure. We just took this for the comparison purpose to validate our improvised step down conversion, I step down conversion. That's possible with just a simple see the circuit. There is no any additional things which we are going which is added in our improved circuit. The circuit is so simple as a like this conventional buck converter. But only the thing is that which that we can notice, which you can notice is a simple coupled inductor concept. Two coupled coils, which we have configured with the same buck converter structure. So that could able to provide that easy I step down operation from this I DC link voltage to the required low voltage, uh, which is required to power the low voltage operating LED lamp. That's the thing. So that's the one simply okay. What is that improvement which we can do? How we can just okay. So a small improvement. And moreover, generally in this in our small simple buck converters, here the device there is some gate driver issue complexity, because here the what is that here? It's a device gate is floating, source and gate. Okay, so there is no proper reference for this gating signal of this in the buck converter. Okay. Uh, and also, moreover, see this switch, if I connected here in this spot along with this inductor pole, coupled inductor, so there was another issue which we have experienced. It is because of the leakage inductance of these two coupled coil could able to actually they lead to very huge transient voltage spike, especially during its turn off process of this device. So then we made a simple thought like that. Instead of keeping this device here in this inductor side, why can't we just keep that device configure device switching device on this return path instead of okay in this, okay, so this path, forward path. So that way we could able to counter that even that use transient, that's just only during the very small time during its turn off process of this device. So that is how we could able to safeguard this device as well. And that's it, say that is due to this coupled inductor leakage inductance of this coupled coils. But at the same time we can able to gain the best advantage of this the steep I step down conversion from this I DC link voltage to the low output voltage required for this LED driver, okay, LED lamp. So with a simple idea, okay, with no further additions, okay, that means we can say, okay, that's the improvement. And that and moreover, another thing is that, see, I was mentioning that this can be operated in the these converters can be operated in the discontinuous conduction mode, so that inherent power factor correction is possible, because that this converter can operate just like a voltage follower in this, because the inductor could able to reset well before the every switching period in this discontinuous conduction mode. Hence, that inherently that peak of that inductor current of this uh, DC power factor correction converter could able to follow this no boundary of this sinusoidal nature. So that is how it can able to make the source current in line with the to follow in line with the source voltage. So that is how that inherent power factor correction could able to achieve with this discontinuous mode of operation. So without any much addition with and with a simple concept of a coupled coil and with this DCM, so we could able to provide I step down conversion. That's the most desirable feature for the low voltage operating LED lamps and also power factor correction. Okay, so that is the thing like that. So these are some of the characteristic waveforms for this our coupled converter. So then all these are the design process, and we took some comparison, and we validated this the performance with respect to this input source voltage variation from 90 volts to 150 volts. We wanted to go till up to even up to 200 volts or 200 volts. So but as we are going for some higher voltage, there is some problem we faced in this. So then we could able to comfortably validate for this 90 to 150 volts within the standards compliant. That is it. Okay. And for the regulation is concerned, the closed loop operation, closed loop controller we have designed so that we could able to provide the constant voltage with respect. Okay, that is the thing. So these are the some of the results which we have analyzed and validated. These are from the simulation counterpart, and also the same thing we validated with this practical validations also for all various RMS voltage of input 90 volts up to 150, 130 volts and 150 volts like that. Okay. Yeah. So I think I already I took enough time. So let me stop at this point. Okay. Mm. So thank you for this opportunity given to share some of the information of our works, what is our students they have been worked on. So possibly if you have any uh, questions based on this
Yeah.
discussions,
Thank you, sir.
so I'm open for your questions.
Thank you, sir. Thank you very much for the wonderful session, sir. So, dear participants, if you have any questions, please ask to sir. Even you can post questions in chat box. We can see one questions in a chat box, sir. Uh,
Okay.
whether LED or CFL, which is best for eyes? Which means why, sir? So, this is a question asked by Dr. M.S. Dinesh, sir.
LED
Or CFL, which is best for eyes?
for okay eye vision. Yeah, of course, it's a very
Ah,
good
yes, sir.
question.
For eye vision. Yes, sir. Yes, sir.
Yeah, yeah. Actually, the one thing is that so these are very high bright output these LED lights will provide, which is not that safe level for our eye vision. That's why, of course, even say though we have a other advantages of this energy efficient and very light high light out efficiency. So obviously we should prefer this LED lights only. But at the same time, even for this aspect, see, we are providing a that no the lighting fixtures, the cover light cover, no the screen. Okay. So that we are trying to provide with a to avoid that glaring effect, which will make the human eye more comfortable. Okay, so that is how general in these LED lights. Otherwise, uh, this sorry, this direct usage of these LED lights for this human eye is not that advisable. Of course, that is also there. Okay, it's a very good point, a good question. Uh, Otherwise, that comes in the design of this light. Okay, the surface. Okay, the kind of a uh, that light fixture for this LED lights, so that that the benefit of these lights can be best utilized without any harmful to our human eyes also. Okay, that is the other thing. Otherwise, these these brightness may be advantages in some aspect, okay, but not for this human vision. Okay.
Thank you, sir. Thank you very much,
Yeah.
sir.
Okay. Sorry.
So,
So any more questions? Like,
yeah. If you have any questions, participants, you can please interact with sir. Okay, sir. We don't have any questions. With your permission, we'll be ending the session, sir.
oh, sure.
Thank you, sir. So, thank you, Dr. Narasimha sir, for delivering a wonderful session on lighting systems. So, your sessions have been fitting conclusions to the technical component of this FTP. So, once again, we, on behalf of the organizing committee and Mission Institute of Technology, Bhimavaram, say a special thanks to you, sir, for accepting our invitation and being a part of this Atal FTP. Thank you very much, sir. Thank you.
Yeah. Okay. Thank you. Thank you all. Thank you so much for giving opportunity.
Thank you, sir.
Okay. So, okay then. So we'll come back again. I think probably you have some other formalities.
Okay. Yes, sir. Sir, at 7:30, sir, at 7:30, we'll
Sure.
be again calling you, sir, for the rejoining the session, sir.
Okay. Okay. I'll
So
just take
meanwhile,
it.
we'll be having online test and feedback sessions with the participants, sir.
Okay. 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 Thank you.
Okay. Thank you, sir. Thank you.
Yeah. Please.
Okay, dear participants, now officially we have completed all the sessions of the Atal FTP successfully. Now, see, we have shared the complete information in WhatsApp as well the chat box of this MS Teams. Please go through that. So each and every participant has to submit the feedback. Please submit your feedback through Atal portal login, your individual login, and then you need to take the test. So if you are if you are getting any technical issues with the Atal login in the online exam, we have provided an external link, Google form, okay, which is dedicated for your online exam. Please submit that link. Okay. I think Dear participants, there is a information for you. There is a technical issue with the existing sheet which we shared. We're not getting the responses. So we are sharing the sheet again. So each and every participant has to submit the newly sent sheet. Okay, we are sharing the sheet in both in WhatsApp and also in the MS Team chat box. Please try to cooperate and try to understand. The existing sheet which we shared is having a technical issue. That's why we are sharing a new sheet again. Okay, you have to submit your online exam with the newly shared sheet. Thank you for your cooperation.
Sir, what about them which who are already submitted the test?
Sir, if you are submitted the test to that link, please ignore that and please resubmit the test with the newly shared link that we are doing, sir. Okay. Same test. Same exam with the newly shared link.
Okay. Okay.
Okay. Thank you. Sir, sir, for Atal ID, please check your Atal login. If you don't find your Atal ID also, no issues, sir. Please type your name correctly. Okay. If you don't access your Atal ID also, no issues, sir. But your name is compulsory. So please follow the newly shared link, sir. Thank you.